Welcome back to Laws of Logarithms, Part 2. Basically, there's no new laws that we're going to run into, but I'm just going to do a few examples here and show you these laws in action. So my first example here is we're going to try to evaluate what this stuff equals. And you notice that they both are base 5. And that really helps because that allows me to combine them with our first law that says if you're adding these logarithms together, then I can just multiply together the 100 and the 1/4. So this would be the same thing as the log base 5. Now what's 100 times 1/4? That's 25. Well, now it's really easy to look at it and say, hey, 5 to what exponent would equal 25? I think this would have to be squared. And so that's my answer. This whole mess turns out to just work out and equal to 2. So not too bad at all. Those laws are very handy indeed. All right, let's evaluate another one that's got some big scary numbers. Okay, the log of 384 base 2. Now we're going to go minus that log of 12 base 2. Now again, these laws don't work if these bases weren't exactly the same. So that's a great coincidence. They happen to be base 2, so I can use the law of logarithms that says if I'm minusing, that's like division. So away we go, 384 divided by 12. And you know, it's as if these things were cooked up to work perfectly. 384 divided by 12, that turns out to be 32. And look how easy this is. I can look at it and say 2 to what exponent would equal 32? By golly, it is a 5. And that is completed. All right, let's clear off the screen and dive into the next one. Yeah. Okay, in the next one, we're going to try to evaluate log base 7 of 49 to the 5th. Okay, now, first things first, see this exponent here? We're going to take that exponent and bring it out in front. So now I have 5 times the log of 49 base 7. So the only trick is figuring out, well, what is log of 49 base 7? Because I know it's 5 times whatever this is. Well, 7 squared would equal 49. So this is actually just equal to 2. And my answer is 10. How easy is that? All right. A couple more examples, and then I think we've done enough. We've had enough. Okay, log base 8 of 2 to the 3/2. Now this one, okay, it's a little, got some fractions in there, and sometimes they can cause a little bit of trouble. First things first, let's take this exponent and bring it out in front. Now there's no reason to leave it as an exponent. So it's 3/2 times log of 2 base 8. Now this one's a little trickier, so I'm going to look at it on the side here. It'd be like saying, so if you've got log of base 8 of 2 equals something, it's kind of like saying 8 to the something has to equal 2. Now where it gets a bit tricky is, clearly this can't be a whole number, or else this whole thing is going to get bigger and bigger, and we want to make it smaller. So you have to hum and haw, and really you got to kind of use a bit of inspection and look at it and say, hey, what if it was 8 to the 1/3? Isn't that the same thing as saying the cube root of 8, and the cube root of 8 is 2? Well, you'd be absolutely correct. So what does that mean back over here? Well, we have 3/2 times, and we just figured out that this guy is 1/3. So I have 3/2 times 1/3. The 3's cancel, and I'm left with 1/2. as my exciting answer. Okay, I have one last example, and then I'm going to stop for today on this. And we're going to try to evaluate a real mess. 1/2 log base 3 of 144 minus log base 3 of 4 plus 2 times log base 3 of 3. Okay, so we've got lots of stuff going on here. So how are we going to tackle this thing? Well, anytime you have these guys on the outside, we're going to bring them in as exponents. So in other words, I think the first thing I'd want to do is this. Bring this in, which is a 144, to the 1/2. Now that's the same as saying the square root of 144. Okay, so this first thing, if I analyze it, actually boils down to nothing other than a log of 12 base 3. Because I happen to know the square root of 144 is 12. Then there's not much I can do with this second guy. There's nothing to simplify immediately with that. But this last guy, to be perfectly honest, I would just look at this, and when I see log of 3 base 3, I know that's just 1. So this is just a 2. Somebody tried to write it in a confusing way. But anyway, that being said, we're just going to leave that guy alone. And now I'm going to see what I can do with these two guys here. Well, they're both base 3, so I can combine them and make this log base 3, and this would be 12 divided by 4, plus 2. So isn't this just saying log base 3, and then 12 divided by 4, that's just 3, plus 2. Well, isn't that just another 1 again? So we're ending up with 1 plus 2. Seems to me this whole thing waters down to a 3. And that would be absolutely correct, and that is where I am going to stop for now. We'll see you in a bit.